Okay, so this is the last lab sheet for this module. All right, it's titled Populating the Cloud. So far what we have been doing in the class is we have been going through all of the most important features of OpenNebula as a cloud solution. So you've installed OpenNebula, you've played around with the Sandstone web interface so that you figure out how to start, stop, make changes to the virtual machines in the cloud and so on. And we've installed Open vSwitch as well so that you can have a general idea of how you can have network cards working inside the cloud. Now the next step is for you to actually build a fully functioning cloud. Now this lab sheet is not very big in itself, it's only one page. All right, the reason for this is that it's pretty much for guidance only. So it comes in two flavors. You can either do everything that is requested of you in this lab sheet. So you can build the 3 virtual machines, you can create the groups and the user accounts, and you can make sure that everybody logs in and they can use those virtual machines. So that will be the bare minimum requirement of this lab sheet. Or you can take it one or more steps further and create a working, complete cloud solution. And that will include services being provided by one or more servers in the cloud and clients being configured to use the cloud in different ways. So the most basic example, the most basic functionality that you can get out of this, the scenario of this lab sheet is that you are building a cloud for a school in a university, let's say the School of Computing where we are. Okay, so we would expect to have at least one server that would provide at the bare minimum file sharing services. All right. And I would expect to have at least one client for lecturers, so for staff that work at the university, and one client for students that can come and use this so that they can use the cloud. Now, ideally, a full-fledged version of this would have more than one services running in this cloud. So you would definitely have centralized authentication. So all of your groups, users, all of their permissions, their home directories and everything else would be managed and administered by that server. And then the clients that you need to set up for your cloud will need to have, at the bare minimum, they need to be set up so that when the lecturers log in and work, all of their data stays saved in that virtual machine. So any lecturer that starts up a virtual machine in the cloud, that virtual machine should be theirs forever, and they should be able to go back to it, start it up again, log into it, and it's their computer. So they should be able to have access to all of their data, all of their personal information and everything else in that virtual machine. So they need to start it up once, and they should be able to use it forever and have all of their data stayed there. The students, on the other hand, should be able to start up virtual machines, use them, so be able to log into them and everything, use any services or any software that might be configured in those clients for the students, but then when they're stopped working, they can either keep the data, save the data that they have in a different location, so you can have, through network file sharing, you can have a different folder available to the students connected to that virtual machine as a second hard drive, essentially. Yeah. And any personal data, anything that they do on that virtual machine itself does not need to be saved. Can get reset or deleted every time they stop using the virtual machine. The most basic principle of all of this is whether you will start up your virtual machines, the instances of your virtual machines in the cloud as persistent or not. Okay, so if a virtual machine is persistent, what it will do is it will create a copy of the image that it depends on, and it will keep that copied image and it will create a new template for that particular user forever. So unless you delete the template and the image that comes with it, then the user's information will stay there forever. It will take up more space in the cloud, but the user can get back to it and can start up that virtual machine, and it's theirs to use for the rest of the semester or the year or whatever it is. All right. If you start up a virtual machine in non-persistent mode, then a student, for example, can use this machine, can use any software in it and so on, But then once they log out and you terminate that virtual machine from the cloud, once it's gone from the cloud and it's gone back to being an image and a template in the cloud, then the students' work, browsing history, any personal information that might have inputted in there and so on, will be lost, will be deleted. Okay, so I'll go into a little bit more detail of how to do this. So what we're asking here, there are various methods to populate the cloud, and I am happy with you to try out whatever you like, all right? But at first, at the very beginning, I would like you to clone your existing images. So you should have a vPrometheus 0 image in your cloud at the moment. I would like you to clone it 2 more times. Use 0 for the server, 1 for the lecturer, and 2 for the student, and that's it. Start them up, give them network cards on net 28, network 30, network 31, make them connect to the internet, check that that you can ping Google and everything else, and so on. Now there's another way to go about this. You can, if you want to, decide to build new images. So you can create completely new virtual machines. I don't care about the operating system that you will use. I have been asked already, and I'm fine with it. Somebody wanted to do this, wanted to build a Windows-based cloud completely. So I'm happy for you to build a Windows server, use Active Directory for account management, whatever you like. Use Windows 10, 11 clients, whatever you want, and you can do this. And if you want to do this, don't forget that the university has a Microsoft subscription that will give you all, as students to the university, licenses for all of the operating systems. Okay, so if you go to portal.azure.com, you should be able to log in there with your university email address and password. And once you activate your account on the portal from the university, you should be able to get licenses for Windows Server Standard 2022, 2016, whatever version you want to use, and Windows 10 and 11. So if you feel like taking on a challenge and doing all of this in Windows, be my guest. Okay, it's fine by me. Me and the assistants in the lab will help you as much as we can. We do know a few things about Windows. We might get stuck at some point, depending on what you decide to do. If you just decide to set up some super weird policy in Active Directory, I might not be able to help you. It's fine. All right. You are here to experiment and learn. All right. So you can do whatever you like. You can install another version of Linux, absolutely whatever you like. You can also go to the marketplace of OpenNebula and download images from there. However, at the first stage, I would recommend against this, because in order to do this, you need to have a very clear grasp of how the cloud actually works, how contextualization actually works in the cloud, and I will talk about this in the next lecture, and how the different virtual machines that you download in containers from the internet need to be configured so that they play nicely with the cloud. All right, you might download the virtual machine that does not have a root password. Okay, and the instructions for the virtual machine will tell you need to add an SSH key as contextualization for this virtual machine in your cloud, and then you can use it. Okay, so there are little details like that on virtual machines that are available on the marketplace. So unless you want to experiment with this and try and figure out how everything works, I would recommend against it. Yes, you can try it, and yes, you can ask for our help in the lab. However, that would be a little bit of an inefficient use of your time and our help in the lab. Okay, because we might also not know how to help you with it, so you might just get stuck and waste your time. All right, if you are going to try something like this, try it outside the lab. If you're confident and you can take it up to a point, then come into the lab and maybe we can help you. If not, try another method. Build something new, use one of the images that we already have, whatever you like. Okay. The key to this is that you make progress and you manage by the first week of May that we're back from the Easter break, you have a fully functioning cloud. All right. So use the existing images that you have or build new ones, whatever you decide to do, and make sure that at the bare minimum you have the scenarios that I will explain now. So the first virtual machine that I would like you to have would be a server. That server, I would like it to live on network 28. All right, So I would like the network card that you allocate to this to be the bridged adapter net28. This is primarily for your convenience and peace of mind. Because it's bridged on subnet 28, internet access will be straight away available to it. Okay, you need to install whatever, yum install, and that's it, and it will just work. All the other virtual machines on nets 30, 31, 32 will require that your routing is working. Okay, so that's just one more level of complexity you could possibly do without while you're configuring your server. And you will need to configure your server because it's not enough just to have the cloud and have one virtual machine that's running and just call it a server. It needs to provide the service. Okay, at the bare minimum, the service I would like you to provide would be file sharing. The easiest way to do this is through NFS. You can in fact just create one file called exports, store it in etc., put one line in there, share one folder in the network, and you're done. Okay, so once you install NFS utils, and create that exports file, you should be able to connect from other computers in that network and use it. All right. Ideally, I would like your server to be able to do user authentication as well. So I would like you to be able to have user accounts that are global to the cloud, not just local user accounts that you create on each of the virtual machines and they log in. I would like for users student 1, student 2, student 3, or give them names, whatever you like, to be able to log in to any of the student-based virtual machines in the cloud. And if you can manage it, I would like them to be able to get access to their home folder, all right, to their home directory. That home directory, the easiest way to go about it is to place it inside the server itself. The cool way to go about it is to place it in the file data store of the cloud and mount it remotely to the user account every time you log in to the computer. Okay, this way when a student logs into a virtual machine, even if it's not persistent, their home data, all of their own personal data, will be saved into the file data store of the cloud, and it will be available for them to use in any kind of virtual machine that they might log on to in the future. This scenario would apply in case, for example, that let's say you have a student and they want to connect to different types of virtual machines in the cloud. You might have a virtual machine that's for everyday use, or you might have a virtual machine that's for specialized use for a particular unit that they might be doing. Okay, the student should be able to log into any of the virtual machines in the cloud, be able to log in to begin with, and ideally have their home folders, their roaming home folders available to use as well. Okay, so this adds one more level of complexity into the thing that I would like ideally to see. All right, so if you can create the server that has authentication and manages the user's logins and data, I will be 100% happy with the server that you've created. Okay, then I need you to create one virtual machine for the lecturer. So you can have multiple virtual machines for your lecturers. They need to be persistent, so when somebody initiates one of those virtual machines, it should stay there and the lecturer's personal data can stay and be stored on that virtual machine, because that's a virtual machine that they will be using for as long as they work in the university or for as long as the year lasts, or whatever the scenario that you decide to be is. Okay. All of these, mind you, you will need to explain it in your logbook. You need to say that the policy that I'm working with is that the server computer will provide these and these services. It will provide them like this through WeldUp or through NFS or whatever else, whatever other technology you want to use. The lecturer computer will need to be persistent, so the data will be saved in that particular directory. They can use it. The virtual machine will be destroyed at the end of July when the year ends, and so on and so forth. All right, so I would like to see a sort of policy for the use of the computers in the cloud to exist in your logbook. Okay, because it's not enough for you to be able to configure stuff. You need to be able to configure stuff and explain to other people what the correct way to use whatever you configured actually is. If you cannot do that, then they won't use everything correctly, and then you'll have a problem. All right. And then finally, the third virtual machine that I want you to create is the student client, which will be a virtual machine that can be non-persistent. It can be as simple as possible, as long as the student can log in, work on it, and then leave and not care about it, then you are fine. All right. If you can have the added benefit of the roaming profiles for the users and they can map their network drive and connect to it and work, that would be ideal. All right. So at the bare minimum for this lab sheet, I need 3 virtual machines to be running. Those 3 virtual machines need to be able to log in their users. Okay. And I'll be okay if you haven't managed to make the roaming profiles. Okay. Just as long as the users can log into the virtual machines and the virtual machines have internet access, so the routing is working on Prometheus as well, you can easily start getting marked from a 70% upwards on the unit. Okay, so the way that marking goes is if you finish all of the lab sheets completely, including OVS, and they are perfect, but you don't have any of this lab sheet, the populating the cloud, you can get up to 68%. Okay, no last lab sheet, no way. Also, if you do the last lab sheet and you make the minimum requirement, so you build the 3 virtual machines and they are running, but your documentation is not the best. Yes, if you've missed documentation, if you missed screenshots, if you've made mistakes and so on, then that will greatly vary what mark you actually get. You can have all the progress in the world, you can have all of the virtual machines and everybody logging in and everything. If you just give me screenshots without explaining the screenshots, I will still give you 50%. Okay, so it's very important that you show me that you understand what's happening on the screenshots, on the documentation that you have created. Okay, I need to know that your friend didn't do it, or the more fun scenario is that you didn't pay somebody else to do it for you. Which is especially brilliant because I will figure this out in the in-class assessment in the last week. Yeah, so keep that in mind. So, it's better to have little progress and understand everything that you have in the logbook rather than just try to have as much progress as possible and have a logbook that is not detailed enough. If you have everything correct up to including OVS and you have the populating the cloud up to the minimum requirement of 3 virtual machines and everything else, I will give you up to 85%. All right. From 85% onwards, I need to see magical things happening in the last lab sheet. All right. But I will very happily give you 100% if you do things. All right. If you get services working and you have the documentation and everything, I'm not one of those people that will say 100% is only for God and 95 is for the lecturer. I don't believe in this. All right. I think I actually gave out 300 or 400% last semester. Okay. So as long as you do the work and you understand what's happening, I'll be fair and generous and I'll give you, whatever mark you like. All right. But these are generally the guidelines for it. Now, to be more practical about it, I have connected onto my computer in the lab and it's now logged me out. So, on my cloud, the images that I have are only these 3. Okay, I have even deleted the CentOS DVD image. I don't need it anymore because I don't need to build any virtual machines anymore, and it's only taking up space. If the DVD is 4.5 gigabytes and you allocate it to a virtual machine that's running, those 4.5 gigabytes will be copied from the image data store to the system data store and end up taking 9 gigabytes of space on your hard drive. Okay, you have a total of 200 gigabytes of space on your Prometheus VMs. If you fill it up with instances of the DVD running 10 times, you lose a quarter of your space. Okay, so once the virtual machine is built, get rid of the DVD, delete the image completely, you don't actually need it. Now I have gone and all I've done is I've cloned the images. So if you select one of the images and scroll down, you can click clone and then log in again because you've left it for so long. It's fine. Okay, so all I need to do is this. Even better, if you want, you can take it one step further and be even more efficient. And you can go to your templates and take one of your templates and clone the entire template itself. And you can clone the template with the images, and that will also clone the template and the images associated with it. So if I want to make a second server now, all I need to do is clone with images, and then I will have a vPrometheus 0 copy, or whatever it names it, image, and then I can start that template up and it will work. Of course, we then need to worry about the networking. And this is where things will get complicated if you decide to run more than 4 virtual machines. So the networking that we've been using so far through OVS has allowed us to create 4 network cards, which are these: net 28, 30, 31, 32. Assuming you'll give 28 to your server and you leave it alone if you want to have one server available there, then you can use networks 30, 31, and 32 to boot up one virtual machine for each. And that's it. Because of the way that we've subnetted the class, we only get 2 IP addresses allocated per subnet, because I try to keep things as simple as possible. I could have supernetted the subnet and give you all lots of addresses beyond a Class C network, but then that would be more fun and possibly more tricky to understand as a concept. Okay. However, what I want you to do, and what is more realistic, is I want you to create one or more new network cards using OVS and assign private IP addresses in them. Okay, you can have them on network 10, 110, whatever. You can have it 192.168, whatever you like. You can really do whatever you like. All right. Those network cards that you create, if I was you, I would create one network card for my students and one network card for my lecturers. I would give a DHCP allocation of an entire Class C subnet, so I can have 254 computers for my students and 254 computers for my lecturers. Okay, once you do that, all you need to do is you need to NAT from Prometheus onto the cloud, or in fact, you can do whatever you like. You can do your own research into OVS, into how the cloud actually works, and you can get your private networks to the outside world. Remember, because they're private networks, they will not be accessible from the outside world. You're only using this configuration because you want to use them as clients, that they want to have access to their server and to the outside world, but you don't necessarily need them to be accessible to the outside world. If you needed them to be accessible to the outside world, there are things that you can do, such as, yes, and its simplest form, port forwarding. Okay, so there are things that you can do, and in fact most clouds in the world work under the assumption that any virtual machines inside them run on private networks. Okay, because terrible ways to have public IP addresses or try to have public IP addresses, you can't really anymore inside a bunch of computers in the cloud. All right, so you need to have a way to give access to your virtual machines from the private network to the outside world. All right, so the general idea of this lab sheet is this. All right, so you need to, at the bare minimum, build 3 virtual machines. You need to be able to run multiple instances of your client VMs. The lecturer ones need to be persistent, the non-lecturer ones need to be non-persistent. Okay, and they need to be able to use the provided services to them in the cloud, and you can decide what those provided services can be. Okay, so we're giving you as much flexibility as we can about how to go about this. The downside is that you might choose to do something weird and wonderful that we might not have a lot of experience with to help you in the lab. All right. However, if you do get it to work in the end, you will have our eternal admiration, Okay. So I would say the first week that you're in the lab, the Wednesday students unfortunately already had a go at this without having the benefit of this lecture to explain everything. Build the 3 virtual machines, make sure that they run, get your screenshots. And then from next week onwards, start worrying about user accounts and the networking access to the outside world. And then from there on, you can start from the third week onwards, installing services and try to configure the networking between the client and the server and how everything should work in the network. So following this plan of attack, you should be able to deal with this lab sheet by the time that we break for Easter. So we have 3 weeks before Easter, and we will have 1 week after we come back after Easter as well to catch up and finish any work that you might want to do. And then the second week after that, it will be assessment week. Okay. Any questions about all this? It is recorded. Please play it back again if you have any questions before you come into the lab next week. Okay. But you start with the basic assumption that get the 3 VMs running, get the networking, make sure that everything works, and then take it from there. Right? One step at a time. Any questions? All right then. Thank you very much. Yes? The assessment is on the week, so I think it's the Wednesday of 10th of May for the Wednesday students, and then Friday the 12th of May for the Friday students. And the deadline for the logbook, the submission, will be at 11 o'clock on Friday the 12th of May.
So the 12th, if you are on the Friday class, that is when we shall do the 1 hour.
Yes, it's not 1 hour. I just come and sit at your computer literally for 5 to 7 minutes, check your logbook, check everything, and then that's it. I will explain how all of this will work as soon as we come back after the Easter break, and I will also give you an example of what the exam will look like as well, so that you... Yeah. So the exam is 1 hour, and from what I've seen on the timetable already, because the draft timetable is out, I think it's on the 24th of May. So I think it's on the 3rd week. I'm sorry, yes, I would like to go to Greece earlier too, but no. All right, so yeah. Yes.
Why do we do port forwarding when we can also check on the network?
You can do whatever you like. Port forwarding was the most simple example to get the private address out. Yeah?
Most of the time we use port forwarding for network and all this standards.
Okay. Anything else? Yes. Create, sorry, what?
Groups.
Yes, of course. So you need to have a group that is possibly students, a group that is lecturers, and maybe all of these will need to belong to a group that's called School of Computing or whatever. Yeah? All right, thank you very much.